In this video, we'll be taking two more examples on velocity and acceleration. Now, the first question, it says the angular displacement theta in radians. Theta radians of a flywheel varies with time t seconds and follows the equation theta is equals to 9t squared minus 2t cubed. Determine A, the angular velocity and acceleration of the flywheel when the time is 1 second and the time when the angular acceleration is 0. Now let's solve that. We were given the angular displacement. Angular displacement. Now we know that the difference between displacement and distance is that one is a vector quantity, which is displacement, and distance is a scalar quantity. So the angular displacement is 9t squared minus t 2t cubed, the unit being in radian. Now the angular velocity, okay, which is given as omega, is differentiating angular displacement with respect to time, and this will be equivalent to 18t minus 6t squared, the unit being in radians per second. Now the angular acceleration, which is given as alpha, is d squared theta over dt squared. That means we are differentiating the displacement 2 times. So we are going to be differentiating the angular velocity, which is 18 minus 12t, and the unit is in radian per second squared. Now the first question, A, it says determine the angular velocity omega and the angular acceleration alpha of the flywheel when time t is equal to 1 second. So when t is equal to 1 second, omega, which is the theta dt at t is equal to 1 second, is 18t. So wherever we see t, we substitute 1 minus 6 into 1 square, and this will give us 12 radians per second. Now the acceleration, that is the squared theta over the t squared at t is equal to 1. We'll have it to give us 18 minus 12 into 1, and this will give us 6 radians per second squared. Now the second question says, what is the time? Determine the time when the angular acceleration is 0. When angular acceleration is equals to 0, c is equals to what? So we know that the expression for angular acceleration as seen in this is 18 minus 12t. So when the angular acceleration is equals to 0, let us make t and evaluate t. Okay, so that means t is equal to 18 divided by 12, and that is 1.5 seconds. Let's go to the second question. It says the distance x meters traveled by a vehicle in time t seconds after the brake is applied is given by this expression. Determine A, the speed of the vehicle in kilometer per hour, okay, at the instant the brakes are applied, and the distance the car travels before it stops. That's question 2. We are given that the distance in meters Okay, is given as x is equal to 20t minus 5 over 3 c squared. The unit is in meters. Now the velocity, that is v, is differentiating distance with respect to t, and that will give us 20 minus 10 over 3 t. The unit is in meters per second. Now with this done, we can evaluate the velocity at time when the brakes are applied. When brakes are applied, time t is equal to 0. Therefore, our v at t is equals to 0 is 20 minus 10 over 3 multiplied by 0, and that will give us 20 meters per second. Now the question says we should determine the speed of the vehicle in kilometers per hour. Okay, now we have to convert 20 meters per second to kilometers per hour, and if you perform it well, the conversion well, will arrive at 72 kilometers per hour, because we understand that 1000 meters is equivalent to 1 kilometers, and 3600 seconds is equivalent to 1 hour. Okay, now B. The second question says determine the distance the car travels before it stops. Now when the car finally stops, that means we are saying the car is no longer in motion. That is, velocity is equals to 0. So if the velocity is equals to 0, we can find the time duration for it to stop. Therefore, we will call from our equation for velocity that v is equals to 20 minus 10 over 3t, which is equivalent to 0 when the car is no longer in motion. So with this, we can evaluate our value of t. T will be equals to 20 times 3 divided by 10, and that is 6 seconds. Now, the question says determine the distance the car has traveled before it stops. The equation for distance given in the question is 20t minus 5 over 3 t squared. Therefore, to evaluate the distance before it stops, we have to substitute the value of t, which is equals to 6 seconds, into distance. So x will be equals to 20 multiplied by 6 minus 5 over 3 multiplied by 6 squared. And this is 120 minus 60, and it will give us 60 meters. So with these 4 examples, 2 in this video and 2 in the previous video, we have been able to establish the fact that when we differentiate distance, we get velocity, and when we further differentiate velocity, we would get acceleration.